I'm Josh, your favorite Java developer. In the last video in this series, we looked at how fuzz testing can be a complementary approach to unit testing and how fuzzing can help reveal blind spots that you might have missed when developing your Java code. To show this, I walked through an example of how to fuzz a popular Java-based open source application for working with databases. And using these techniques, we were able to find a very severe remote code execution in this popular library. So in this tutorial, I want to show you how to do the same. And in particular, we're going to use CI Fuzz, a command line based fuzzer, to look for issues in Java code and beyond.
So here's my application, and I will make this a little bigger. So this is, let's do this. Okay, so here's my main application. It is a very basic, very buggy command line based application called RoadSmart. So it is a CRUD based application for inputting and outputting data related to major highways and major roads in various parts of the world. So let's see what it does just for completeness. So I'm going to run this. Oh, look. So welcome to RoadSmart, the intelligent tool for getting road information. So maybe I want to read all the roads, what's in this database. So here's some roads. Pacific Coast Highway, I-95, 401, Bundesautobahn in Germany. So these are some roads. Maybe I want to add a new one. So can I create one? Yes, I can. So I'm going to have, in addition to the 401, there's the 402, both major highways in Ontario and Canada. And this is in Canada. So I do this, and then I can also read. And then I'll see I've added down here the 401 with some information around speed limits and length of the highway. So, and then I can also print. Maybe I can print this to XML. Maybe there's some kind of output format that is preferred. So it's a realistic application, a little simple, but the kind of thing you might use Java for. So here is a piece of code, again, kind of trivial kind of thing where you might have this analyzer class, and the analyzer class has a method where you process an array. Maybe it's a complicated processing operation. You have to do some kind of element by element management of what's going on in your input. So I have this thing. And so I kind of follow this classic pattern of I'm going to take this array input. I'm going to make a copy of this array, make a copy of it piecewise or element wise, and then I'll process the copy. Now, of course, I'm just doubling every value. That's an array of integers, but imagine this is something like very complicated. So this looks straightforward. There is a very subtle, I think, a very subtle bug somewhere in this code. It's 20 lines of Java, which isn't very much. So you can take a look and try to guess where the you could try to guess where this bug is. Again, making an array, make a copy, sort of element-wise copy, and then do some kind of processing, and then return the output. So so I've written this. It's excellent code, I think. Let's test it. So let's say I think, okay, I want to make sure that this code works. So I will write a unit test. Could maybe test-driven development, right? Like very good advice. Write a unit test to understand what your code is doing. So I create an instance of this analyzer, and so I arrange some kind of version of this analyzer to execute. And then I'm going to make this like this. Okay. So I'm going to arrange some kind of fixture to test. I'm going to perform an action. So I'm going to call my complex processing method using some kind of input. And I'm going to compare it to some kind of expected input versus an actual output of the actual method under test. And then I'm going to assert that this action, or I'm going to assert that something is correct. So maybe the input array needs to preserve size. So if I have 3 elements in the input, I should have 3 elements in the output. So let's run this and see what I get. And it runs and passes. So like I've written a unit test. Things look good. I've checked sizes, right? Like so far so good. But I still have this bug. So what I'm going to do is, in addition to this unit test, which just tests the functionality of this method under test, I can also fuzz this. I can also create a fuzz test. So again, this is in Java. This is in the same class. And so what I'm going to do to generate this, I'm going to use my CI Fuzz. So I've installed CI Fuzz. You can definitely take a look at the installation. CI Fuzz, create, and I'm going to create a Java fuzz test. And it creates this test stub, my class fuzz test 1. So this is now located in the root of my project. Okay, and this is just a fuzz. This is just a stub. So I can copy and paste this and add in some details as needed. The two things that this provides me that's very helpful are the fuzz test annotation. So this tells JUnit that like this is actually a fuzz test. So handle this differently from an at test from a standard JUnit. From a standard JUnit unit test. And I also get this fuzz data provider. So this is the key. This is the thing that will help me generate those fuzzy inputs. So, and I would just get rid of this. So imagine that I have cleaned all this up. Just delete. There we go. I've cleaned all this up and moved this into my unit test class. And so now I have this fuzz test. So again, I follow the same kind of pattern. I'm going to create a fixture, this analyzer class under test. And then I'm going to call this method that I'd like to test. And I'm going to use this fuzz data provider to pass in some kind of int, right? This is what I'm looking for. I'm looking for some kind of array of integers. And so this data provider can provide that functionality. It can say, okay, give me an array of integers. I could also get an array of strings, a single string, an int, et cetera, et cetera. But in this case, I need an array of integers. And so then I'm going to run this from CI Fuzz. So CI Fuzz command line. So CI Fuzz run, and I'm going to call my class name. So analyzer test. So this builds and runs in kind of a standard way, but then it also runs this additional fuzzing process, right? So this executes great. And look, CI Fuzz has a finding. It finds an issue. It gives that issue a name. It gives it some kind of name so that you can reference that later. Kind of standard SecOps kind of a way to go. And it provides an out of memory issue. So I've found an issue, I found an error, and I found my out of memory error. Let's see where that bug is. I know you've been waiting with bated breath. So the bug is on line 15. So very subtle bug, easy to miss, particularly if you think about like maybe this is code you haven't written, maybe you're new to a code base. This really should be incrementing this way, right? You should really be going through and incrementing your position sort of, +1. But instead of calling the actual position, the bug is calling the reference to the array. So this could get wildly out of hand, right? Like if this value becomes an integer like 40 or 50, this could kind of grow. There's also sort of use case, or there could be test cases, like imagine you have inputs of an array of zeros. So this will just keep going back to 0, and then this infinite loop will just continue, or this loop will become infinite and always kind of walk through. So that's where the error is. And again, subtle error, functional error. If you want to think of this as an error that a developer would make in development, something that anyone could do. But CI Fuzz was able to find this in pretty short order. So that's really good. So definitely take a look. So again, definitely take a look at the examples in that GitHub repo. You can run this yourself, set it all up. You can kind of take a look and kind of try this yourself as well. So let's take a look at SQL injection. So here we have a class. And I'll close all this up. So here we have a class again. So we have this CRUD application. And again, just for demonstration purposes, I'm using an in-memory database. Of course, you probably want to persist your data somewhere on a disk somewhere, but for this case, I'm just going to use it in memory, but it works exactly the same. So I have this information database class, and this handles various operations I might want to do with my database. This creates an initial database. It inserts a few values like here. Again, these could come from some other data source. Maybe there's an existing database that you migrate your data from, or maybe there's a CSV file that is used to generate things. But there's also some additional functionality here. So like you can insert road data based on a road object, right? It's pretty good, Java way to go is, pass objects around and communicate via objects. But you can insert data, you could read all data, select star from roads, the kind of classic, like get all the information, and delete. So like there's some kind of things in here, and it's relatively, similar to how you might code things in real life, right? You might have some kind of database operation where you're pulling things out or inserting data, that kind of thing. So here I want to, just zone out a little bit. So here I have my information database fuzz test. This also creates a unit test as well. And it's got some setup and all this kind of business here. But what I really want to look at is comparing these two tests. So following the same pattern as before, we have a unit test to verify, like, can I insert, and this might be the very first unit test that you write. If you're test driving something, you might want to say, can I insert data? Can I insert data into my SQL database somehow? If you're sort of working with a legacy code base and you're thinking, I need to get a handle on this, I need to understand how this works, you write a unit test to, can I insert data in a way that I expect? So this is a unit test to verify the functionality of inserting data. Again, I'm talking about SQL. So I have these two actions here where I arrange my test fixtures. So I initialize a database instance or access a database instance. And then I create a test road, right? A fixture, and pass in like a valid string. And this is, I'm just using a static or fixed string data for this, right? All I'm doing is saying, okay, give me this object. The object has a string. The string is valid and it's fixed and it's static. So I kind of I arrange my fixtures. I perform an action. Can I insert this road data? So I act, and then I have an assertion. So I assert, did my result work? Was it able to insert properly? Assert true. And so let's run this. Runs and passes, right? So far so good. Maybe I'm a developer and I'm a backend developer and I just want to be able to insert my test data, and go home and have some nice glue wine, this kind of thing. So functionally, this gives me some confidence that this works, that my information database class kind of works the way I think it does with respect to inserting data. But I'm also going to write the same, and if you look like line by line, the setup is exactly the same for this fuzz test. So I'm going to have my fuzz test annotation provided by the JUnit package from Code Intelligence. And I have my fuzzed data provider. So this actually provides my fuzzy data to input things. So I set up my database and instantiate it somehow. Here, and I'm going to do exactly the same steps. I create a road fixture, and then I perform my insertion operation, and then, did my insertion operation work, right? Do I get the result I expect? The key difference, these are line by line exactly the same. Sort of an arrange, act, assert, so-called AAA unit test. Same structure for the fuzz test. The difference is, instead of using fixed or sort of constant data, I'm going to use generated fuzz data. So I'm going to have my fuzzy data inserted here into my test fixture, and then pass that into my method under test. So, and because I'm in IntelliJ, I've cleverly set up, and I'll show you this. So in addition to running standard JUnit tests, I also have a shell script. So instead of going to the command line every time, I've just set up CI Fuzz run with my test file, or I guess, my test class file. So I can just run it right from the comfort of my command line. So I'm going to do that. Okay, so I'm going to click this and run up here. So this builds, Maven does some things, it runs and checks, and let's see what I get. And I get a SQL injection. So again, in a few seconds, I have a piece of software using SQL, and that SQL seems to work. I'm able to insert data appropriately. Sorry, I have some junior colleagues that are joining down here, very junior colleagues. But while this works functionally, and my unit tests do provide some value in seeing, that my inputting works, or my data insertion works, I'm able to use fuzz testing to reveal a SQL injection. And if I go back and take a look, you'll see that the SQL injection makes sense. I'm basically just inputting values via string. I'm not doing any sort of prepared statements or any data sanitation. I'm just trusting the user input. These row get name, get country are just strings. They could be malicious. It's possible that these strings are sort of maladapted to drop data or to kind of perform unexpected actions with my database. So yeah, like dropping tables, dropping databases, performing malicious inserts or data collection, that kind of thing. So yes, so I'm able to find this SQL injection in short order using CI Fuzz. So that's pretty good. And again, this example also fully available. You can definitely run it from the GitHub project as well, kind of play around with it. And pull requests and issues welcome.